Hey guys, this is Tori from Hats Tutors, and as the next part of our series on organic chemistry, we're going to be talking about how to name alkynes. So what are alkynes? Well, alkynes have the formula of CnH2n minus 2. They are hydrocarbons joined by one or more triple bonds. They are unsaturated hydrocarbons because they have triple bonds instead of only single bonds. So for instance, let me draw but2-ine. This would be but2-ine. And if you're wondering why I drew it as a straight line instead of the usual jagged pattern, I'll go on and explain this later. Properties of alkynes. Like alkenes and alkanes, they are nonpolar, but due to the presence of pi bonds and not just sigma bonds such as in alkanes, they are more reactive than alkanes. If you want to learn more about pi and sigma bonds, you can look into the valence bond theory. And they also have a boiling point at negative 84 degrees Celsius. So naming alkynes. Similar to alkenes, find the longest continuous chain of atoms that contain the alkyne. Specifically, longest continuous chain of carbons. So you want to number the main chain in a way so that the carbon number of the triple bond is reduced. Similar to alkenes, you change the ending of "ene" for alkenes to "-ine and insert the carbon number between the body name of the alkyne and the "-ine. Separate the number with dashes on both sides. And then you name the branches and substituents. This is basically the same as naming alkenes. It's just that the ending will be alkyne. It's really simple. So let's go over a quick example. In this case, we have 4,4-dimethyl pent-2-ine. But let's think about how we reach this conclusion. First, let's identify the main chain. The horizontal chain is the main chain. Of course, you can also use the L-shaped ones over from top to over here, and bottom to the main part over here. However, the most obvious one is the horizontal chain. Next, let's identify the location of the triple bond. The triple bond is over here. And now we have to think about how to minimize the triple bond by numbering. For instance, if we number from left to right, we would have 1, 2, 3. The third carbon would be responsible for the triple bond. However, if we number from right to left, it would be 1, 2, and the second carbon would be the carbon with the triple bond. And this reduces the number of the triple bond, so you want to number from right to left. So 1, 2, 3, 4, 5. So the main chain would be pent-2-ine. And now let's identify the substituents. Both the methyl groups are attached to the fourth carbon, so it would be 4,4-dimethyl. 4,4-dimethyl pent-2-ine. So structural property of alkynes. Unlike alkenes, alkynes do not have geometric isomers. So recall cis-trans or EZ isomers. Instead, alkynes have a linear Vesper structure relative to the triple bond. And this linear Vesper structure is what we're trying to communicate with the straight line diagrams instead of the usual jagged ones. So let's name the following. First, let's identify the main chain. This should be the main chain. And now let's number the carbon so that the triple bond number carbon is reduced. So I can infer that numbering from left to right shouldn't reduce the triple bond number. So 1, 2, 3, 4, 5. So then we can identify the main body chain as pent-2-ine. And now on the fourth carbon, we see that there's a methyl attached. So it would be 4-methyl pent-2-ine. So let's look at this one. Well, the main chain I can see is still the horizontal one. Of course, you can go like this and like this, but the horizontal one is the easiest to identify. So we notice that the triple bond is on the first carbon if we number from right to left. So obviously we want to number from right to left then. 1, 2, 3, 4, 5, 6. And now let's name the main chain. So it would be hex-1-ine. And now let's look at the substituents. So on the third carbon we have an ethyl group over here and a propyl group over here. And on the fifth carbon we have a methyl group over here. So let's look at the alphabetical ordering of these groups. Ethyl before methyl and methyl before propyl. So then we know that it would be 3 ethyl, 5 methyl, 3 propyl, hex, 1 yne. And that's how you name both of these. So drawing alkynes. As previously stated, alkynes have a linear structure. A linear structure constitutes the bond angle of 180 degrees about the triple bond. This means that the 2 carbons triple bond into one another, and the 2 carbons adjacent to these 2 carbons have to be drawn in a straight line. So let's go over some examples. Here we have hex 3 yne, and let's go over how to draw it. Well, usually you want to start from the triple bond. So let's just draw a triple bond, and let's draw the 2 carbons adjacent to them. So this would be the second carbon, this would be the third carbon, this would be the fourth carbon, and this would be the fifth carbon. So we need to add 1 carbon on each end. So let's add carbon number 1 and carbon number 5. And this would be hex 3 yne. As you can see, 1, 2, 3, 4, 5, 6 carbons, and with the triple bond on the third carbon. So let's go over the second one now. The second one would be 5 ethyl oc 3 yne, and let's go over the oc 3 yne first then. As always, let's start with the triple bond and the 2 adjacent carbons. So now we have a chain of 4 carbons, and this would be the second carbon, so we need to add 1, and this would be the first carbon. So 1, 2, 3, 4, 5. Now we have 5 carbons, we just need to draw the rest. So now this should be oc 3 yne. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons with the triple bond on the third carbon. And now let's draw the 5 ethyl now. 1, 2, 3, 4, 5. This is the fifth carbon, so let's draw an ethyl group here. And this should be 5 ethyl oc 3 yne. So once again, I would like to thank you guys for watching the video. I hope you guys have a great day, and I hope you guys learned something. Goodbye.